Hey guys, so today, like I promised on another video, we're gonna go over a small project, to be honest, house, a small sample house, uh, but there's um, a lot of interesting items to account for on the takeoff, and I think all those tools that I showed on the previous videos, we're gonna use them today, and we're gonna take off all the house and see what is waiting for us. It is, I think, a 2500 house with the basement, first, second, and attic floor with the rafters on top. So it's gonna be cool to deal with the pitch tools, pitch math, and let's see how we can go. Hey guys. So I'm gonna start recording my screen. It's already open, the PlanSwift. Let's create a project, right? So let's go with new. I'll just put this number here. Sample house. Let's store locally. English measurement type. Cool. We just search for the there you go. Next, and it's downloading. Cool. So the folder that I used on my computer, it's already imported. We have all the 13 plans. Let's start by understanding the project. Okay, so this is the cover page. We have the basement, cool. First floor, second floor, then the attic, roof plans, elevations, okay, with the dormer. This building section is showing a lot of details for us. Okay. I found it odd to have, because zip wall is the structural sheeting outside, but it's also is asking for a tieback. So this house is gonna ask for 2 AVBs. That's gonna drive the price up, but let's follow the plans. Okay, there's a spacing here. Strappings, type of plywood, in this case Advantech. Okay, some rally columns on the basement, some rafters, color ties, plywood. Okay, now we have the structural. We have just 2x10s, regular 2x10s with some beams. The second floor is pretty much the same. Attic and roof. Okay. I always like to start with the walls. So let's go through the basement. Let me just rename. All right. So as we can see, 1 second. Here, section, I can open a new tab. So what I did here, just to help navigation. Okay, so the basement, we have the exterior walls are concrete, so don't worry about that. what we should account for is the lally columns, right? It says right here, lally columns. So on every footing, we have a lally column. Cool. So looks like the basement doesn't have a lot of walls, just the interior staircase. Okay. Cool. Let's check the structure to see if those wall. So the first floor will be this floor right here that I'm highlighting in pink. Okay, but the plans show all these details and also everything below. So we're seeing all the framing below as well in terms of walls. Okay, that logic applies on top. So if we see the second floor framing, we're seeing the first floor wall. So everything is below. Okay, so this is the first floor framing. Looks like the walls are not structural because I have these beams here, and let me see the first floor. So I think so, yeah, these walls will be on top of those beams. So the basement wall is just a partition. Okay, all right. Yeah, it's not carrying any loads. What is carrying the load on the basement is the outside footing walls, exterior walls, these lally columns, and these LVLs. Okay, so it's just a matter of wall closing. So let's consider that as a partition. Okay, so let's go over the templates. I changed a little bit my templates just to give some speed to my takeoffs. I created this area and budget. It's just a math I did to account for walls, partition walls inside an area. So instead of going over each and every partition, drawing them up, I just draw one area because we're gonna take off areas anyways, right? For labor and stuff, budgets. So I converted all the work of linear footage into area. How did I do that? So basically, if you remember, walls are linear, based on lines, linear footage. Instead of linear footage, you see area divided by 10. In my experience, I saw an average between 90 and 120, 110 linear footage every 1,000 square footage of partitions. So at every 1,000 linear footage, I have 100 feet of walls. So 100 divided by 1,000 is like a factor of 10, for 10. So 1 linear footage of walls for every 10 square footage of area, and the PlanSwift is doing the rest. So it's taking that area divided by 10 as the linear footage and then doing the math. So if it's studs, it's gonna account for spacing and stuff, area, the plates and blockings, the linear footage divided by the length. So it's just a matter of gaining speed. So it's really one of the main focus here. It had to be a quality takeoff, but also you have to provide volume and speed. And by doing so, you're gonna save time without compromising quality. Okay. And we have some waste inputted, so I wouldn't worry too much. I think it's a good way to go, in my opinion. So let's go by that. So I'll just create. Oop, I forgot to scale. Good thing about the software, he reminds you to scale. So I already have the scale. Okay. Let's check the dimensions. Check one here. Okay, we're fine. Cool. That's a basement. Cool. But instead of drawing the whole area, let's just draw around this staircase. Okay. Cool. Let's just put a little bit more area just to account for a little bit more. It's not gonna drive the price down or up. It's just a matter of gaining speed here. Okay. All right. Cool. All right, I think we're pretty much done with the walls here. Now okay, let's go with the lally columns. Just put an example here. Just steel with concrete. They have this base and the post caps to attach usually on the basement. This is something we provide as a carpenter, even so it's not wood. Okay, very common on old renovation buildings and small houses like this one. So just a matter of accounting for the points. So I don't have that template here, so we just use general to create. Lally column. Okay, we're in a basement. So 3.5 on every concrete footing. So we have 3 here and 3 more in here. Let's okay, lally columns. Let's count them with this one. So 3.5 by. Okay, so let's check the height. Let's put 12 for now. So just one, and it's a post. Let's not account for waste because we know exactly how many we have. So let's go on this intersection. 8'7". Let me just scale this up. Oh, so the lally column should be around 8 feet. They can adjust them on site, so let's accounting for 8 feet, okay? Instead of the 12, so 8 feet. Cool. Alrighty. Right, let's move up to the next floor. Let's rename that and then scale it up. Okay, so let's start with the exterior walls. Exterior walls are, there we go, 2x6s at 16. So okay, we have, okay, so exterior walls, I have the studding spacing, I have the number of plates, so 1 on the bottom, 2 on top. The sheeting, let's put a zip wall with Tyvek. The height, I have it right here, 9, 11 and a quarter. I'll round up that to 10 to simplify math. And yeah, I think that's all, right? Okay, cool. Let's go back to the first floor. Okay, so let's create exterior wall. It's a 2x6 at 16. The height is 9, 11 and a quarter. Let's put 10. on the first floor. Okay, let's start. Okay, let's nice. So by clicking here, it was a point to point or a box. So I just saw it as it's a rectangle. So I just save timing here. All right. Cool. So okay, so the height is 911. So the stud is a single stud, 2 by 6 by 10. So it's enough. It's 16. I don't need the very bottom to be pressure treated because it's not in contact with the concrete. So let's put the bottom blocking, top plates, very top plates. It's half an inch zip system. Oh, bracing for temporary and seal. I don't have it because it's not in contact with concrete. We'll count that for these 2 plates on the bottom. Okay. All right. Okay, so the zip, we need the taping. Yeah, because zip system, zip system sheeting. As we can see, the seams are supposed to be taped. These are 4 by 8s. Okay. The tape, it's 3 1/4 by 90 feet. Okay. Let me just do quick here. Just so I can explain the math. Imagine the sheets are 4 by 8s. So it's 4 by 8s, 4 and 8 feet. It's not gonna be perfect on a wall, but imagine if we stack all the sheets on an organized way. Okay. So let's put together 6 sheets. Okay. Everything the same size. Okay. 4 feet, 4 feet. Okay, cool. How much is the perimeter, you think? Summing everything up, because that's what we're supposed to do with the taping, right? We're supposed to tape all the seams. So by doing so, we need to figure out the linear footage of each and every one. It's not the sum of the perimeter of one sheet times the number of sheet, because is one they share the same, so you'll be accounting for much more. Okay, so how much is this linear footage total in here? I mean, if I have 6, it's easy to do just a sum up, right? But imagine if I have a lot of sheets put together. That'll be complicated, right? But within these 6, we can come up with a number of tapes required to tape a sheet, right? So let's do a quick math in here. We have 8 plus 8, 16 times 4, 16 times 1, 2, 3, 4, going this way. So 4 times 16 plus 12 plus 3, right? So 3 plus 12. So here we have 64, here we have 36. Summing them up, we have 10, 100. 100 feet. So remember, one tape, it's 3 1/4, which doesn't matter on the math here, but by 90 feet. So as you can see, pretty close. As we go further with the math, I mean, putting together more and more sheets until infinity, this number right here, 100, is gonna keep going down, 95, 93, until a lot of sheets put together close to infinity is gonna come close to the 90 number. So that's why zip tells you on the literature that one row of 90 feet installs 6 sheets. So with all this logic, we can apply to the math in here. So to account the tapes, let's reuse this sheeting right here. So I just drag and drop, and let's put 3 3¾ by 90 seam zip tape. 90 feet. Let's put each. So going to advanced. So this is the number of sheets. So dividing that by 6 gives me the total rows number, right? Cool. And then plus the waste. So let's put 0. Let's put 5 just to play safe. Okay. Now we have the tie vac. I think I have a. Let me see. Okay, I have a plugin for tie vac in here. Let's just drag and drop. Just hit OK for now. Let me see. I go into advanced. Actually, let me just go material here. It's okay. Okay, so the plugin is working with the linear footage in the total. It's a line, so and the math makes sense. So one row is fine. Cool. So I guess, yeah, the exterior wall is done. Let's move to interior walls. So the section in here. All right, let's see the second frame looking down. As you can see, these walls shown in here, if they're shown in here, they are structural. Okay. So let's remember that shape. Oh, pretty much all these walls in here are structural, leaving almost no partitions. So I'll work here. Actually, let me just check the. Okay, so let's just put in pink. So just the pink walls are partitions because they're not shown and by exclusion. So let's just account for these ones then. Let me just delete, so not be on the way. Let's okay, so now I had to figure out, is it a shear wall or a bearing wall? Okay, it's not indicating any type of sheeting. I think we can go without sheeting. Do not say anything. Small house, probably there's no need for interior shear walls, just exterior. And we can make sure in our proposal it's excluding interior shear walls, just to cover our pricing. So let's go by bearing wall. So in my experience, you can see the difference of thickness of the wall, and we can also see the dimension here, 5.5. So this is a 2x6, this one is a 2x4s. But with experience, you can see the difference, okay? And this is a 2x6, probably because of the bath and for plumbing and stuff. All right, so pretty much everything is a bearing wall, 2x4. Okay, so we start creating and start drawing. Cool. Let me just create 2x6 real quick. Let me differentiate the color. Okay, so let's check this here. 2x4x10 is 16. So the floor is 10 feet, 9, 11.25, so it's fine. No need for pressure it because we're not in contact with concrete. Blocking is okay. Same for 2x6. Cool. Okay, let's do our thing for the budget. Cool. All right. Actually, I should play on the safe side. Let's just take the whole floor for budget, okay? I just thought, because this average like 90, 100, 105 linear footage at every 1,000, it's considering areas without partition, you know, corridor areas. So let's just put everything, we'll just be covering, and the math respects that. Even so, we just have a stair here. I don't think it's gonna be a problem. I'm just playing the safe side. It's not gonna drive the price too high. Okay, so yeah, let's just do the same thing here, and we take advantage of already taking the square footage off, I think. Cool. All right. Okay, now let me see what is worth to take off, because we cannot take off every single item on this house, like blockings, just use the budget. A jacking, just use the waste of the studs, which is 20%, which is higher than normal. I think let's just take off the structural headers. And okay, so structural headers, let's see the structural. Okay, typical headers are double 2x10s up to 5 feet, and double LVLs for up to 9. Okay, let's use the header here. First floor, I'm gonna start with 2x10s. If I see something bigger than 5, I'll just stop instead of checking every single one. I'll just go. So I don't take off exactly the window. I just go a little bit just to play on the safe side, and because the header is not the window arrow itself, it's a slightly bigger. I'm just playing safe here. So 3.5, less than 5, less than 5, less than 5, less than 5, bigger than 5. We'll just hold that for now. Hold it. Let's hold it. Okay. Cool. I just checked the material, so it's a double 2x10. To be honest, in my experience, doubles work for 2x4s, exterior walls at 2x6s, and to make it flush, we need 3 for drywall. I'll just okay, so there's a 2x4 wall, which is a 3.5. If we put 2 headers, or just exaggerate, okay. If we put 2 headers in here, it's 1.5 each. So it leaves us at 3 inches. So we're missing 1/2 inch. So we just infill that with some plywood, okay. But if this is a 2x6, 5.5, we just need to put 1 more. Not gonna fill everything with plywood, doesn't make any sense. It's easier to just put another 2x, giving us 4.5, right? And then infill 2 times with plywood, because we're missing 1 inch. So 2 times 1/2, right? So in my experience, I think it's gonna be better that we estimate triple 2x10s for 2x6s and double for 2x4s. That will apply for LVL as well, okay? Let's just play on the safe side. So just keep 3. 2x10 is 16. These are almost 4. So I'll just cut them in 4 pieces. So 16 is fine. Jacking is not a PSL. LVL. Okay. So the jackings, they just not account because there's a lot of waste into the studs, so it's already accounting for jackings. And also in going over openings, so it's accounting. I mean, there's the window. As we do the takeoff, we don't stop the linear here for the studs, just keep going. So it's already accounting studs inside the window that we usually not going to use. So the math will help us to account these as jackings, okay? Just to go quicker, it's not gonna affect the pricing of the project. So just a matter of taking out the header. Cool. And okay, so the plywood spacer, we in my experiences, we can add something here, but small, just a few headers. We can use the waste of the outside zip to account for the cost for these ones. It's not worth my time putting it. Let's just keep going. Let's create a header for the the larger than 5 span, right? LVL headers on the first floor. Just these 3. Cool. Okay. Okay, let's just count for. It's a double LVL. but let's apply the same logic. LVLs are 1.75 inches. So for 2x6s, we need 3, right? 3 times 1.75 inches is 5.25. So almost 5.5. So we can account for 3 instead of 2, playing safe. So it's 1.75 by 9.5. LVL, we don't account the third dimension. I'll explain that in a bit. Let's just finish here. Okay, actually it's 3, right? So number of plates is 3. Okay, so imagine an LVL 10 feet, but the same LVL is 12. The price by linear footage is the same. So let's say it's $2 per linear footage. The 10 feet will be 20 bucks. The 12 footers will be 24. So in estimating purposes, it doesn't matter if we account if it's an LVL of 10, 12, we just come up with the price, right? So it'd be faster just to account the total linear footage instead of going on each and every one. Oh, this is supposed to be a 10 footer, it's supposed to be a 12 footer. If they're not the same, the fluctuation it's within like less than 5%. But on the other hand, the 2x, so let's say a 2x4x10 and a 2x4x14. The price per linear footage is not the same. They are completely different. It can be double. It can be 50% difference. So we have to come up with the third dimension for estimating purposes, you know. And this is a good tip for you. If you're purchasing material 2x4x10, try and price the 2x4x12. It might be cheaper, or might be cheaper by the foot. So if you're doing cuts, it'll be cheaper for you. So use less materials, right? Cool. So let's apply that here. That's why I just come up with the feet, and here number of pieces, and for pricing purposes. So have the walls, headers, okay. Let's just okay, let's go up to the second floor. Second floor. Scale that up. Cool. Cool. I'll just copy it and see if it matches. So I'll just select 2 times, right click on the green, copy it, paste, right click on the name here, paste, new item. If it's same, they'll be linked. Different floors, I'll change an information here so it doesn't change the next one, the previous one. So just go new. Takes the time, not too much, because small, literally not a lot of layers. I'll just turn off everything, go one by one. So okay, the interior wall, the exterior wall looks fine. Nothing to change. Let's just see the section. Okay, so the height, it's 1 foot less. Probably okay. Let's keep 10. Probably a pre-cut stud. 104 inches and 5/8. But let's keep it at 10, estimating purposes. Okay, now same tie back, same everything. Okay. Okay, one thing before I forgot, I just always change after I copy, I change the first item, and then I'll go to estimate, just because this is a it follows a timeline. So this is, if I change the first one, I know this is the first one of the list up top, so everything down, it's within that page. So by clicking here, holding shift on the keyboard and clicking here down, you select everything, right click, fill down, so all the information goes here. I just refresh and everything is changed like that for second floor. So good tip for you. So let's stay with texture wall. Let's see, bearing walls, I have some changes. Let's see, we're in the second floor, so we have to look at the attic. Ooh, a lot more structural walls. Okay. I'll just print. To save it on my other screen here, so I can compare. All right. So this one is out. Okay, so I'll just keep. Okay, these change to 2x6s, so let's adjust that down. Adjust that here. Okay, these are right here, 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 here. The other one, the 2x6s, here. Cool. Let me just paint here so you guys can compare. So, right, these are the structure ones. Cool. Now let's see. Same thing from previous floor, nothing's changed. Okay, now we have a little bit more 2x6s bearing walls. So let's move here. So by holding shift, by holding the alternative keyboard, I can just move it around. So okay, here. Actually, this one in the middle are also the stairs. They're also structural. Okay. Cool. Are we missing any walls? I don't think so. Nice. So the area stays the same. Cool. Partition, actually the headers don't have everything here. Okay. These look like 2x10s. Less than 5. Cool. I guess we don't need the alveols here anymore. Okay. Let's move up to the attic. All right. A little different because of this shape here. The rafters coming up, just a dormer. But we can Let's copy everything up again. I'll just put attic. Put a scale. Check. Roughly. Cool. We're cool. You get the gist. You got the gist, right? It's pretty standard. You just do the first one and start copying and modifying. So copy it, paste, new. Cool. I'll just change the first third. I don't think I have attic here. I'll just put third floor. Estimating everything down is third floor, right? Holding shifts down, view down, refresh. Cool. Everything off one by one. Let's see. Okay, so okay, let's count this way. Let me see the elevation. Section. So yeah, these are the rafters are coming down this way. That's why the wall go this way. So, but we're gonna account for rafters later on the structural. Okay. Cool. Okay, so exterior walls. Let me just. Okay, let's just check the height and see. Okay, it's less. Let's go by less than. Let's go by 8. So just double click 8. Oh, actually, we can go 9 at least for the sheeting and drive the price down because sheetings are top 5 on pricing, like stud sheetings. So let's not overprice those. Okay, the stud can go to 8 feet. Cool. All right. Let's see. Okay, barrels are messy. Let's see the attic. Oh, actually, the okay. So just the exterior walls are structural. No interior. Everything's partitioned, so just delete those. Okay. And our budget will take care of it, right? Cool. Let's see our headers. We might have some, just move here. We might have some alveolus in here. Yes. Okay. Alveol header. I'll, instead of creating another one, I'll just go into estimating, actually templates, create a auxiliary folder, just so I can drag and drop here, so I can modify for the third floor. Cool. All right. What else we have here? walls. Okay, I think we can jump into the structural because the everything will be on the structural. So let's start by the first floor. Has some joists, beams, and the plywood and blockings. And let's account for these doubles here. Okay, let's scale it up. Okay, here. There's no way to verify, but we can verify 32 by 24. Which is exactly what we have here. Cool. Okay, so let's start taking the perimeter. So we can account for these plates, the seal, actually, yeah, the seal, and the ring board. Cool. Let's go into general. Mortise plates. For framing. It's a rectangle. Save some time already. Cool. So it's two plates. Um, 2 plates. BT press treated green. 216 air plates. Uh, seal. We can take them from the walls. Drag and drop. Ring boards. Let's put a line. 2 by 10 by 16. Just one. Rings. Cool. All right. Now let's start taking. Okay, let's take this solid block in here. 2 by 10 solid. On that first solid framing. It's a middle span to block everything, make it more rigid. I think we can just, yeah, use this one and change to solid blocking. Oh, now let's start taking these. Um, yeah, I'll take advantage of those. Same drawing. Close joists. Let's check out the span again. 14 footers. Yeah, 14. Here, 16. 14 footers. Okay. Okay, so this is point on a line like studs. So let's 2 by 10, 14. So at every, what it's saying here, every 16, I'll account for one 2 by 10 by 14. Exactly what it's doing here. Um, like if we have, jeez, hold on. If we have joists on a certain space, if we cross a line at a certain spacing, so if you divide the length of this line by the spacing, you're gonna find out how many points, right? You have. That's exactly what we're doing in here. So in a 45 feet span, which is these two, at every 16, I account for 1, 2 by 10, or 14. Okay. Cool. I'll just put into auxiliary so we can create one for in here and here. These are almost 8. So I'll use 16 two times. Don't need the block anymore. So a 16 can be used at 32. So because I used them 2 times, cut it in the middle. In here we have almost 5. So we're gonna use the 16s again, but 3 times. 16, 3 times 16. Cool. Now let's plywood. Oh, this is going very well. Very simple house. Take a look on all the lines, areas, and points. Going over the templates. Floor area. There's no pitch. This is the first framing. Let's take advantage of this one. Cool. It says Advantech in here. Um, Blue safety rail. Strong backs for trusses. We don't have it. Flooring. It said, okay, so it said right here. This is by the carpenter. If not, it's resilient channel, metal by the metal drywaller. Uh, so safety rail is just a temporary protection around the perimeter, like these ones. Strong backs for trusses to hold trusses together. We have 2 by 10, so we don't need those here. And the 1 by 3s, if it's not, it's a resilient channel on the ceiling, drywall. So instead of the 1 by 3s, these metals, this is the most common ones. The 1 by 3 is more for small houses like these ones. But we have to provide it as a carpentry. Okay, so it stays. Cool. Now we have the beams. We forgot the beams, man. Cool. Everything's a double LVL, so okay, we can use the same template. 2 by 10 LVLs. Just use the same template. Cool. Okay. Drag and drop. 1 3/4. Double. Cool. All right. Let's go up. Let's just click here. Scale. Let's see if it's still 24. Cool, by 32. Okay, let's just crop everything. Ooh, Jesus. Repeat. Second framing. First framing. Paste new item. Takes a second. Let's change the first one. Estimating this one down. Few down. Cool. Let's see. Okay, so in here we don't have the seal anymore, or just the ring boards, because we're doing this one. So just the ring board. The solid stays. Cool. Cool. Area. And okay, we don't have things here anymore. Just up top. Okay. Okay. Let's just see the attic. More of the same. So just copy and let's keep going. Attic framing. Scale. Check. 24. 32. Cool. Paste it. New item. Check one by one. Ring boards. Okay. Solid blockings and joists. All right. And here as well. Cool. Floor, the same. Okay. Just moved for some reason. Not aligned. Okay. All right. Pretty easy, huh? Once you do the first floor. Now let's check the roof. Ooh, the roof is more difficult. Let's just start understanding the roof, because we have a bunch of rafters in here. You see, let me just, so we have the rafter in here, different pits. We have ceiling joists, collar ties. Okay, let's just put a scale on it. 24. Looking a little bit more because, okay, so it's in here. 24, 22. Oh, because the roof goes a little bit over, like that, fit over to create a soffit. Okay, here's a little bit more complicated, but let's go over it. Okay, let's go by the roof. Up top, we have a pitch of 4.25 by 12. So all these joists here, they have a certain length, which is, let's measure scale. Okay, let's just see a roughly number for these rafters. 14 footer. Okay, let's use the logic. 2 by 10 by 14 rafter up on a roof. That's 16. Yes. Oh, actually no. This one. It's 2 by 10. Actually, let's just account as 16. Just to place on the safer side. But these cuts right here, they are a little trick to do on the field. So let's go by 16, just to play on the safe side. Nice. Using our experience to do estimates. I love that. Um, okay, 16, 16 here. Doesn't affect the math, just the material. Cool. Now these ones down. Let's see the pitch. Ooh, more steeper. 12, 12s. Okay, so they are these ones here. 20 footers. Okay, playing safe. Let's just auxiliary. 20 footers. Just these and these. 20 footers. Okay. Now these. Let's check by elevation and see. They are 5 3/4. I'll just scale up just to see a dimension. Oh, 12 footers. I just let's just estimate as 14. Actually, it was 16 just to take advantage of these right here. Just instead of creating another one. Okay. Let's just put one here to account for everything in here. Cool. Nice. Color ties. These color ties, they are straight, no pitch attached. They are to secure them like that. Color tie rafters. So just a matter of no pitch, okay? Now we just measure them here. 10. Let's put 10 footers. Color time. And every 16. Color tie. The rafter. Okay. Okay. Do we have a ridge? Ridge is the beam on top, like this one right here. So no pitch. This one right here. These are the ceiling joists. You see exactly our roof on this example. Okay, so we can account for this alveolar reach. 1 3/4 by 14. Just one ridge. Cool. We have more ridges in here. 11/7/8. 2/12 alveolars ridge. But now we have to account for pitches. Let's just try to not lose layer here. Okay. Let me just understand the pitch. Okay, so it's 5.75 by 12. There are these ones right here. Okay, it's 3/4 by 11/7/8. Just one, the pitch. Okay, let's just put one for now. Let me just find out what's the pitch. How much should I multiply actually? I think I have a tool here for pitch. No, it's not telling me. Okay, let me just do the math on my own. Um, okay, so the math is a triangle of 5.75. Let's put a 6 to make it easier. By 12, we have to come up with this number here, x, and then divide x by 12 because what we are seeing is the on plan, right? Is the 12. Actually, the correct error is the x. So how many times x is bigger than 12? That's the factor that we're gonna multiply to correct the area and find out the real area. Okay. So to find x is the square of 6 multiplied by 6 plus 12 multiplied by 12. That's 36 plus 144 square. So it's 36 plus 144 square, 13.41 divided by 12. 13.41 divided by 12, 1.12. So 12% more. So I'll put 1.12 here. 1.12. Cool. So 54 plus 12%, 61. Okay, cool. And now what do we have? The sheeting, right? The roof sheeting. So just use this template here. Okay, so on top it's, let me see the roof. 4.25, 5. Okay, so I'll just keep it 6, these ones and these ones to use the same layer, and these were are 12s, okay? So just keep here 6, and here is always 12. Okay, so right here and here. Okay, uh, the roof sheeting, oh, say right here 5/8 CDX. So 5/8 CDX plywood. Okay, corrected by the pitch with the wastes. No need for strong bed, no trusses, but we do have the furring. Cool. No glue for the roof. No safety rails, no nothing, just the sheet itself. Cool. Let's create a 12 by 12. 12 by 12, which is a 45. And just modify the color here. What I'll do is just go over and subtract later. Use the snap, boom, boom, boom. Cool. I'll just drag and drop. We're gonna accept the pitch. Cool. All right. Now what do we have left? Okay, we have the ceiling joists with no pitch. So they're going, so they're going this way. Going this way right here. Ceiling joists. Okay. So just check the span 24, 24. Okay, I'll just put 2 of 12. They encoding the meter. They're not structural, just to create the ceiling. So I'll just okay. So we have this one right here. Let's just account 2 by 8s by 12s to 16. So what I'm doing here is 1 second. We have the unit and the ceiling joist. This is a 24. So if I account for 12, they're gonna part in the middle. I can do um a nailer here, connect them together. It's not structural, it's just to close and make a flat surface for here. We can put it on top of the walls, make an overlap, so no biggie. That's why it's two. Okay. And yeah, I think this is missing rafters, nothing. There's no fascia here for the siding. There's fascia, no subfascia. Cool. I think that's it, right? What else am I missing? I think that's all for wood. We have all the structural, the lily columns, the partitions, the first floor walls, second floor walls, the attic, all the framing, and the rafters. Right. All right, guys, this is a house sample done in less than 2 hours. So cool. Um, if you have any questions, just let me know. Put it in the comments and we can go over, okay? Other than that, I'll see you guys later. Much appreciated. Bye.